at your packet and pick up where we left off. Well, it's 6.1 and 6.2. I just happened to flip to here. So I think I'm going to look at this, and there's two more I'm going to fill in right now. And then just tell you that these three are the ones we're covering tonight. 1, 2, 3. So if you flip over here to 6.2, and on 4 and 5, I want to write in others that we'll see next week. Difference of two squares. Some of these, if you've taken, which some of you have, an algebra class in the past, and a little more recently, it'll sound familiar. Factoring, okay, difference of two squares might be something that rings a bell. And the rest of you, if it doesn't, don't worry about it. We're going to figure out what that is next week. Difference. It's just titles. These are titles. It's almost like power rule is a title for exponents. Just a title. Difference. Difference of two squares. And then there's difference. So eventually we're going to cover all 5, and tonight we're going to go for sure GCF. This is 6.1, and this is 6.1. And trial and error, guess and check. There's easy, and then there's hard. And today will be easy. This will be 6.2. So the hard ones are going to be on next week. Next week gives you a chance to work out these other ones during the weekend first, and then we'll come back to Tuesday. All right, let's flip to 6.1. Anybody know what a prime? Fine, I've got the definition there. Let's say, anybody know what a prime number is? And somebody just, well, let me just read it right here, Jeff. You guys have heard of prime numbers? No? Yeah? No? Okay, Brandy's saying yeah. Caitlin's saying yeah. Donica's never heard of it. Okay, prime number. That's okay if you have not heard of a prime number. Okay. Sierra, you ever heard of prime numbers? Oh, yeah. Okay, good. Some people don't know, especially non-math people. You guys are math people because you're taking math classes. I'm going to show you something here. See if I can bring it up. They put some things in movies.
Oh, you're going to show one of the movies?
I got time. I might show 2. Ooh,
Yay!
We'll take a little movie break early. Okay, I got to show you. I got to share my screen of. See if I can bring it up. Where do I want to go? Home. Okay, do home. All right, so down here, a while back, I had the opportunity. It's called a sabbatical. Just give me 1 second. So I had one sabbatical. Okay, what a sabbatical is. We can apply, and we have to have a project, and we get a semester off paid. And but we got a project, so it's not just, hey, it's a vacation. So it's something that we've always had an interest in, and it gives us time to work on it. and then come back and report on it and do something with it. So what I did is I always knew that there were, a long time ago, there were movies that had mathematics in it. That was either talked about, spoken, or demonstrated, or written down or something like that. And I knew of some of the movies already. And so what I needed to do, this is about 20 years ago, or 15, well, not 20, 15 years ago. 15 years ago, I needed to take the movies that I had on DVDs or on VHS and create little clips and put it on YouTube. But some of the YouTube ones went off because they didn't like that it was Sony. Let's say Sony. Hey, you're not supposed to put one of our clips on without getting permission. So Vimeo, I think, not Vimeo. There's one where you send money, and there's another one you can put up videos like this one. So I spent time doing that, putting it on, creating the movie clips, creating little modules and some things around the concepts. So I have 15 of them here. There's a lot more that are out there. I only have the time to do this many. And then, so if I click on this, you can find this. And you can see, I created a kind of a basic web page. And, there's little modules right here. This is for the students, for you guys, if you want to look at it, like history on what? What's this one on? Oh, Pythagorean formula right there. Can you see this, Jan?
Yeah.
Okay. And so there's places where you can hit the clip and watch like the Wizard of Oz. Anyway, so let's see. A couple of these have the topic's prime numbers. Okay, let's see. Prime. Oh, this is Pythagorean formula.
I think contact.
Yeah, contact's one of it. I got it there. I'm looking at maybe some other new ones. Pi, this about pi and pi and pi, lots of pi stuff. Prime numbers. Okay, there's contact. Fibonacci numbers. Distance equals rate times time. Distance rate times time. Math word problems. Algebra word problem. Work-related problems. Fibonacci. Is that the only one that I had on Prime? One more time?
Last one on the top. It started with like
the one on the top? Okay, let's see what the one on the top was.
Oh, stealth.
Oh, that's Prime. I mean, that's not Prime numbers. That's stealth. Yeah. Okay, this is a good one. Let's do stealth. This is on Prime. So what I'm going to show you is, gosh, you start wondering, even the Hollywood producers and the actors are just reading the script. Hollywood producers, are they getting it right? And some of my clips, they get the math wrong, totally wrong. And what were they doing? Why did they do that? So I've got 15 of them. You can take a look. I'm going to do this one and see what they say. Who's they? Well, you got Jamie Foxx and you got Jessica Biel. And Josh Lucas. These are three major actors, actresses. And he talks about prime numbers. So let's see. Let's see if this works. Click. Let's see. Maybe it will. Maybe it won't. Can you see this, Jan, coming up?
Yep.
Okay. Oh, yeah. Okay, so it's going to work. All right. Let's see. Turn my volume up.
Popsicles in the cooler. Help yourself.
That'd be great.
I believe there is one left, and don't lose your dignity.
Oh, thank you. Hey,
All right, take a seat.
nice catch.
Talk to me. Where are the holes? How can we improve? Come on, I'm not a patient man.
Sorry, Captain, I got caught up on that west wall. I had to pull out before I could even get.
War is a team sport. Those AAA sites were thick. Gave some extra time to the SAM sites.
See, that's your answer. There really was no room for improvement. Actually, what Lieutenant Wade did was right. She took out their communications, and then she exposed the position of their SAM sites so Henry could come in and lay it down.
Because that's what I did.
It was perfect.
Perfect. Well,
What is going on? Could be my internet. Ooh. Too much data? What? Let's see. No, I've got my internet. What is going on? What are you doing? Pause it. Start it again.
I'll go along with that. Much as I hate to see that smile of yours getting me smugger.
You blush?
Good news.
Tell us we got a carrier, Skipper. Come on.
Affirmative. The USS Abraham Lincoln. Captain's an old classmate of mine, Dick Marshfield. I believe you two know each other?
He was the captain I was telling you about, right?
Can't wait to
A hell of a pilot in his day.
He's black, too.
But
I'm also going to be expanding your squadron. On the carrier, you'll be joined by a new wingman.
A fourth wingman?
wait, I thought there were only 3 Talons in existence.
What is the problem, Purcell? You look like you've just been hit in the gut.
For one, Captain, we've been flying together for a long time, and it's good. And 4 is an unlucky number.
Unlucky.
Yeah, it's not a prime number. See, prime numbers can only be divided by 1 or itself. 3 is a prime number, the Holy Trinity. The thesis and the antithesis come together and form the synthesis,
Look,
which is
this
like
is not a
spiritual.
seminar on metaphysics, son. This is the U.S. Navy. Now, we ship out Wednesday at 0500. Dismissed.
Okay. Let me finish. I was going to say 3's company, 3 Stooges, 3 Musketeers, 3 Pete, 3 Strikes Out,
Yeah.
3 times a lady,
3 dimensions.
3 blind mice.
Menage a trois, don't forget that one.
Okay, there's 1. And what he said is true. It's a number that's divisible by 1 in itself. So at least they did it right, at least on Hollywood. Let's see, there was another one. Let's do the contact. Let's do contact. Let's see. So contact's been around for a while. Jodie Foster, she's a scientist. We can read it here. She's a scientist. She, along with other scientists, hear pulse sequences from outer space. The scientists use the computer. You'll see how old the computer is and how old the movie then is, to convert the pulses into numbers. These numbers turn out to be the prime numbers from 2 to 101. Okay, let's see what happens.
After 30 days, I could not believe my before and after picture. I literally rolled back the hands of time.
Sorry. Okay, skip. There it is. And yeah, I don't need all that introduction stuff. Don't need that. And we don't need that stuff. Okay.
You just have to turn your volume back on, Jeff.
All right, let me hear it. Make me a liar, fish.
It could be AWACS out of Kirtland jamming us, but I'm doubting it.
See, Bud's reading it too. Willie, patch it back and give me the off backs. Are we recording?
Never stopped.
Thank you, Elmer.
AWACS status is negative.
What about White Sands?
On this frequency, no.
This is fine tonight, guys. Come on.
It's not tracking any snoops in this vector. Shuttle Endeavor's in sleep mode.
Okay, point source confirmed. Whatever it is, it ain't local.
Position?
I checked interferometry somewhere in Lyra, I think.
Vega?
Can't be. Only 26 light years away.
Hey, what's the peak intensity?
Coming up.
Vega. Andy, a bunch of times there are SIBOs. Negative results, always.
Got it. Reading over 100 jet skis.
Jesus. Pick it up on my...
All right, it's restarting. Wait a minute. Those are numbers. That was a 3. The one before it was a 2. Base 10 numbers. Just start counting now. See how far we can get. 1. 7. Primes. 2, 3, 5, 7. Those are all prime numbers. And there's no way that's an actual phenomenon.
Holy
Okay,
shit.
let's just calm down and pull up the star file on Vega.
It doesn't make any sense. The system is too
Zero
young,
main
so it can't have a
sequence
planetary
best for
system,
4 million
let
years
alone
old.
life,
This
let alone
is
a
increasing
precipitous
this no
civilization.
Well, maybe they didn't grow up there. Maybe they're just visiting. I don't know.
Okay, so spacecraft? No, this system is full of debris. It would get clobbered.
Well, not if they use their laser blasters and photon torpedoes.
It's not funny, Willie.
Well, how else are we going to explain it? That's what you're talking about.
Willie's
here.
right. If we go public with this and we're wrong, that's it. It's over. We're cooked. God, I wish Cat was here.
Whatever the signal is, we better do something soon. Vega's going to set.
Deposition is confirmed. We've got 4.4623 gigahertz. Confirmed. We've got 112 Jansky's.
All right, do you have a source location yet?
We put it right smack in the middle. Vega.
Okay, thanks, Ian. Just keep tracking, and we'll get back to you.
Yeah, righto.
Okay.
Okay, so now this was the interesting thing when I did this, because he's going to say every prime number between 2 and 101. And I wondered if that was true. Maybe they missed one, or maybe one of those is not even a prime number. Did they screw it up? It turns out they got them all. So I checked them, and there's not a bad one in there, and they got them all. So anyway, that was the clip. There you go.
Hey, Jeff,
All
don't
got
go.
time to do that.
You have 91 in your
Uh-oh.
book. You have 91 in your book. They didn't put 91 on there.
Well, that's the question. See, I'll show you this. I don't think I made a comment about that in the other class. I didn't read through the whole thing. So here, let me read through my. All right, so yeah, 2, 3, 5, blah, blah, blah. Notice 2 is the only even number. It's called a prime. And if it's not a prime, it's called a composite. If it's not prime, it's called composite. Like the number 6 is composite because 2 and 3 go into it besides 1 and 6. Blah, 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 blah. And so Jan is, okay, let me see. From the list below, are there any numbers that are not prime? Aha. So Jan is wondering, I don't know if, did you say 91?
Yep. They
Oh.
just didn't have it on the list in the movie. So I was wondering.
Oh, hold it. I wonder if it's maybe not prime. Remember, my question is, are any of these,
Right.
There's 3 of them. See, I didn't do this with the other class. Not all
Oh,
of these are prime. I'm going to see if we can find 3 of them that are not. Let's see if we can find them. I wonder if
91. Yeah, 91 can be divided by 7.
Well, there you go. Okay, so there's one. That's why I don't have it on the movie. So 91 divided by 7. There you go. Okay, so, yep, 91. It's got to be odd, so. Okay, anybody
Oh,
find it?
no, 91.
Oh, yes, thank you. Well, maybe 97. Thank you, thank you, thank you.
83, I believe.
Okay, 83 is divisible by what?
7.
Okay, let's try that. Divided by 7. No, looks like that's okay.
No? Okay.
So 83 is okay. Well, at least divisible by 7. You might try some other numbers. But definitely 91. 97's okay. So erase this. This one's okay. So far, nobody's checked it.
Oh, wait. 91, so it'd be 14. 14.
If it was an even number, you'd say, throw that out. But they're all odd numbers, so they all have a chance. I've got 2 more. Supposedly, if I said there's 3 of them. I did it right. Yeah, there you go.
It's the first time I've even ever noticed that after the last couple of years that 3 of them are not prime.
Right.
It's so funny.
Never noticed. It never got brought up, and I never went over it quickly. Well, I think you'd know that the first few are okay. You know, I'd say those are okay. Probably that one's okay. And I think that one's all right. Oh, I think. So maybe from 37 on, maybe. Oh, say it again. No?
Emily,
Oh.
Emily.
I thought it was so much as I got the answer. No, it's an Emily. So not 91. 91's bad. Oh, well, Jan says, look at the movie. Let's have you not look at the movie. I can see the movie and you can't.
Yeah, to see. I'm looking, I Googled it. I'm trying to find.
Oh, there you go. There you go.
Hundreds one.
Okay, so what goes into 100 to 1 evenly other than 101? Okay, stop working so hard. I'm looking at the list. All right, they're all prime after that. I think I got to change this. You know, that's a typo. Okay, there are one of them. I should put some more in there. Oh, I threw you off. It threw me off too. If I looked at his list, you know, the movie list, they got them all.
Yeah, I just looked, Jeff, and
Except 91. 91's not a good one. Okay, so I got to change that. There are. Oh,
there is one.
Yeah. So I might say there are 2 of them. I'll have to come up with another one. And that's a typo, and I'm going to change that for my next in last semester. I'll come up with another one to stick in there, and I'll dog ear this. Never found a mistake there. Sometimes mistakes come up when you least expect them. Hey, this is not a published, edited, it's edited by me, document. You only pay $20 for it. It's not like you pay a bunch of money. Okay, well, now we know all these are prime numbers. Now, when I look at down here, the number 90, 3 times 30. Come up with 2 numbers that give you 90. This is called factors. Okay, factors. What are factors? Factors are any number that divide evenly into, including composites, into the number 90 in this case. Like 10. 10 is a factor of 90 because 10 goes into 90. 9 is a factor of 90, and so on. Now, what we want to do is prime factors. We're going to bust up the numbers into little prime numbers, products of them all. So if I start off with 3 times 30, some of you remember this. I think this in my maybe high school algebra class. I might have been taught this like a factor tree, like this. You know, if I said, oh, 3 times 30. Remember doing that? Maybe some of you, maybe not. All right. Instead of doing it this way and guess and check, I can do, all right, 30 can be 3 times 10. 10 is 2 times 5. And you're all done. These are all little prime numbers. So the product of all these, which is the same as this, gives you 90. So likewise over here. Now, when you're in this section called factoring, you're looking, there's a phrase called common factors, what they have in common. So I'm going to circle in orange, I guess. Okay, they both have a 2. They both have a 2. They both don't have a 5. Okay, only circle, oh, right here. Only circle 1 for 1 here, common factors. So common factor, if I do this, common factors are 2, 3, and also the product which is 6. The product of these numbers is a common factor. Well, think about it. Does the 6 go into 24? Of course it does. Does 6 go into 90 and say, oh, I don't know. I don't know. I mean, that's what you do. Is maybe a calculator and you go like 90 divided by 6. Oh yeah, 6 goes into 90. So 6 is a common factor and 6 is the biggest. So you want to find the biggest common, or we call it the greatest common factor, the GCF. 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 Yeah, the greatest common factor. You know, we have a lot of acronyms in mathematics. Well, I don't know what a lot is. Gosh, maybe 10. More, probably more. LCD. LCD. Anybody remember or know what mathematics LCD means?
Lowest common denominator.
Right, lowest or least, you could say. Good, Donica. How about FOIL? FOIL. We should all know that, right? Yeah, we all know that. There's 3 right there. Okay, how about this one? LCM. LCM.
Least common multiple?
Good for you. That's right. That's exactly right. So there's 4 so far. I don't know, Jan, can anything come to your mind? Mathematical. I said LCD and FOIL. Those are all acronyms for something.
PEMDAS, of course.
Yes. Okay, good. I like that. PEMDAS so far. So that's all you guys should know, all those 5. Anything in the future, Jan? Any future ones that beyond this course that you can remember?
Oh, how far forward do you want me to go? Trigonometry?
Sure. Go as far as you remember.
Let's see, sine and...
Yeah, but sine, S-I-N or S-I-N-E are not, it's not an acronym for anything.
See, oh, you're right. Gotcha.
Letters stand for something.
I'm trying to think like calculus or trigonometry, but I can't remember anything.
Okay. All right, let's say we stop at those 5 for now. These are the ones that will be familiar to you. How about LOL? You know, how about IRS? You know, you guys are millennials. You know what LOL means. I mean, IRS. There's other. Millennials live their life on acronyms. That's what they do. I think that's what you guys do with, I don't know, texting or tweeting. Or seems like it. A lot of.
Wait a minute. You have a non-millennial here.
Yeah. Maybe not all of you. Yeah. You are doing the LOL right now. You are laughing out loud. Yeah.
I am. I was forced to learn all that.
But you know this.
Oh yeah.
Right? Oh yeah. Or a CPA, certified public accountant, and you know NA. That's not an A. Oh my gosh. NASA. NASA. 4 letters that mean something. National Aeronautical Space and Agency. I think. I don't know.
Oh.
Might be.
Impressed.
STEM. We have a new building that's being built, SRJC, that will, well, who knows when that's going to be built because everything stopped over there. The STEM building. Let's see if I get this right. Science, technology, engineering, and mathematics. STEM courses. So yeah, you've got a lot of things that are acronyms. Okay, so going over here, what we're going to do is try to factor off terms. Now, the other ones were just numbers. 90 and 24 were numbers. Here we're going to have 2 terms, variables, and your job is to come up with the greatest, that's the biggest, and we'll start with number. The biggest number that will go into 3 and 9 evenly, the greatest, which I think you know is 3. And then if they both have variables, then you ask, do they both have the same variable? Because if they do, you got some more stuff to do. This one doesn't. So if that's the only thing you can, what they call factor off, then you're going to write down what's left over so that when you check, remember doing chapter 5 goes the other direction. Chapter 5 would take this problem and say multiply and get that as an answer. Chapter 6 says take this, go backwards, tear it apart, and that's your answer. Are these like terms? No, they're not. You know that. Those are not like terms. Okay, well, let's see. I'm going to factor. What number goes into 3 and 6? 1. Boring. Don't, yeah. Okay, how about 2? No, 2 doesn't go into 3. How about 3? Yeah, 3 goes into both. How about 6? No, 6 doesn't go over here. Okay, so 3 comes out. All right, both of them have x's and y's. Do both of them have x squareds and y squareds? So think of this as like, let's see, 3x, x, y, y, plus 3, 2, x, y. I'm going to circle what they have in common. They both have a 3. They both have an x and a y. All right, so I'm going to take the 3 off, the x off, and the y off. Here they are. And then what's left over is an x and a y, and a plus, and a 2. Because if you checked it by distributing, you should get back to where you started from. So we'll call this factoring, greatest common factoring. Okay, this one here, sure, I can take a 3 off. I can take an x off because they both have an x. That's all I can do. So now I'm going to take a 3 and an x off of this. That leaves me an x left over. Okay, so this one here, it's interesting because I'm going to take the 3 and the x off, and you say, well, what's left over? And you say, nothing. Well, no, there's something. You don't want to leave a 0. There's something. Because you have to go and put it back together again to check it, sure. You'd have to go over here and stick it on something, which is the number 1. Put a subtraction right here. So that would be considered the boxed answer or a factored form.
Can I just ask a clarification question?
Yeah, Brooke.
So when we're looking for the greatest common factor, we're actually looking, I'm just a little confused on the example side because it looks like you're getting the greatest common factor of both terms.
That's correct. No, that's totally correct what you're doing. You're looking at what's common to both, or like here, here's 3 terms, 1, 2, 3. What's common to all 3?
Okay.
What is
Sorry,
common?
that may not make sense, but the way
Okay.
I'm seeing it is not.
Back up here. This one?
Yeah.
Okay, so I busted it up. Maybe confused you more. Maybe I'll.
Oh, no. You know what? As soon as you put your finger over it, I saw it.
Oh.
So you're taking, basically what you're doing is that I guess, so I'm looking at the 3x2y, 3x squared and y squared right there. Okay. So
then I rewrote it as x times x is x squared, x times x, y times y. 6 is 3 times 2 because those are prime numbers, and xy. So they both have, what's in common to both terms? This is one term, this is the first term, that's the second term. They both have a 3, so I circled them.
oh, you know what? I see it now.
And both of them have an x. And both have
Yeah, I was getting tripped up on what I'm getting tripped up on. Never mind. Disregard everything I just asked. No one pay attention to me.
Right. As long as you're getting it, do you think you're understanding it?
Yeah, I think where I'm getting tripped up is that the factored form is actually the equation, and we're using the answer to find the equation.
Oh, answer.
Does that make
Answer
Does that
being,
make sense?
is this your answer right here? Is that what you're
Yeah.
saying? Yeah.
Yeah.
So this was the answer in chapter 5.
Yes. Yes.
So the answer in chapter 5, and this is your answer in chapter 6.
Got it.
This is how you started in chapter 5 to get your answer over here. So now we're starting this way and we're going backwards.
No lie, I'm not really thrilled about what we're venturing into, but I'll go there.
Oh, I got it. Let's see. These F words.
Oh yeah, love those. Some of my favorites.
I won't put any 4-letter ones down, okay?
It's a 4-letter F word for sure.
Okay.
Foil, F-O-I-L. I got it.
Okay, I didn't think about that. F-O-I-L. There's an F word. It's not even a
That's
word.
my 4-letter.
Okay, fractions. There's another word. Okay, that's scary, right?
Don't like those either.
I know that. That's why I'm writing it down. Factoring or factor. Yep, those are
Yeah, kind of going off of what Brooke was saying, and now that I'm thinking about it, what do we use factoring for? Like, does it go into something else that's like more important? Like, why do we need to know how to reverse it?
Okay. Why are we even in an algebra math class? What good is this going to change my life about? Gotten that question for 40 years, 30 years, or something like that.
Not what I meant.
I know that. But you know what? If you're taking the next course after that, let's just say it'll help you. You need it. You'll need it. Let's say in my course, you guys are learning how to be little problem solvers. So real world, when is this used in the real world? Real world? I don't know.
That's not true. I just told you guys 3 weeks ago I'm remodeling my loft, and I used
Factoring?
this. I don't want to admit it, but well, I mean, there were parts of it where I had to use it. I had to factor so that I could figure out, how much paint I needed to buy so I wasn't underbuying or overbuying, or the same with the lumber to do the trim. I'm not ready to go there to say that I used algebra in everyday occurrence, but it may have happened, but we're not actually saying that out loud to anybody on the internet in a video that's being recorded. Thank you.
I'm curious how you're using factoring, though. That's really, I would say, totally get the idea that you're using mathematics to help you make choices.
The algebra. It's the algebra.
The algebra.
Yeah, I totally get that. Yeah, I totally get that. So basically, Rosie, yeah, you're going to use possibly something in your life, and you go, let's see, how do I find out how much square yards I need of carpeting in my house? I'm going to trust the person at the store.
So I just have a really quick question. Is this basically we're taking just so I can wrap my mind around it, because I do use calculations every day, but they're not like this.
No, they aren't.
No, I actually calculate board footage lumber every day. So this is just taking the answer and reversing it back, right?
That's it.
Okay, I just want to make sure I'm like understanding how to do it, because I do a bunch of stuff for like wood, and I have to take it from a piece price back to like something else. So I just want to make sure I'm kind of.
You and Brooke are doing it. That's it. Okay, so look at this. Here's Jan may have done some of these problems. Okay, so this is what 5.3. Where's my pen? Okay, so 5.3. You had this is your answer. Excuse me. This is your problem, and your answer was to FOIL. One of Brooke's favorite words. I can't even say it. Foil. Okay, so then probably most of you are pretty good at this now. 6x squared, and then what, 10x, and subtract 9x, and subtract 15. Collect like terms, you get 6x squared, plus an x, and subtract 15. And you say, well, okay, well, I'm done, box that. What good is that in life? Probably not a lot. But you're problem solving because you just learned a process. And so that helps. That's a good thing in job skills, like Brooke and maybe, I think that was Betty that was talking about her job. So this is chapter 5.3. Okay, now in 6.4, I think so. 6.4, we're not there yet. Your problem will be saying factor 6x squared plus x subtract 15. It'll say factor that thing, factor that. So it won't look like this. It'll say factor that thing. And what you're trying to do is come up with the strategy, which is my job is to teach you the strategy, so that your answer is back over here. That's your answer. So you don't know how to do this one. This one's a hard one. You don't have, so tonight, nothing like that, but that's the idea. Everything in chapter 5, you're undoing, going backwards. And it's hard. And the better you get at it, if you can get pretty good at it, feel okay about it, then chapter 7 will be better in our course because chapter 7 uses factoring. Also, if you're taking another math class like 156, some of you may be choosing that direction. 156, you'll be using it. The instructor usually says, oh, let's do some factoring again. Let's do some for some purpose, some reason. Let's do some factoring. So you will use it in another math class. If you're doing statistics, probably not. Statistics is a different animal altogether. Okay, so that's about the best explanation I can give. Sorry. The process. So, okay, what's the GCF here? Everybody's got an X. Write down what's left over. That's it. That's the answer. 3 terms. 3 terms. Okay, got it. Trinomial. Sure. Okay, so no like terms. Okay. What do you want me to do, Jeff? Factor. F-A-C-T-O-R. Completely. What does that mean? Complete. Complete. Factor completely. Factor all the way. Sometimes, and I don't know if it'll be tonight, but later on, next week, sometimes they'll give you a problem where you have 2 or maybe 3 different steps, 2 or 3 different factor methods you have to use. What's the factor methods again? They're over here. Here's one factor method. Here's a second one. Here's a third one, fourth one, and fifth one. And by the way, when I put them here, its order is important. You know how PEMDAS? Order is important. Remember that? Yeah. So for factoring, to make your life easier, remember, you always, every problem, ask if there's a GCF first. If you skip and say, oh my gosh, I'm excited because I can see this thing, whatever this thing is, I can do that. If you go and forget that, you may not be able to do it, or you skipped over something else that you should have done first. So do that first. If you can't do that, fine. Then ask yourself, I wonder if I can do grouping, whatever that is. If you can, good. Don't stop. And then ask whatever's left over, can you do this one? If you can't, then you're done. So you go down the list. Right now, the only thing I've taught you is the GCF. There's nothing else. So there's no go down the list. It's just stop. But once we start building on this, then you will go down the list. So what's my GCF here, anybody? What's my greatest common factor?
2.
Okay, does 2 go into 9?
No.
Okay, so I can't do 2.
Well,
maybe.
But
say again?
8 and 9 don't have a common factor.
1, but that's boring.
Oh.
Don't do 1.
Yes.
Okay, so you're not going to have, Brooke, a number. What about letters?
B.
One more time, B.
Oh.
B.
B. Okay, I see B. They all have B's. Do they all have B squares?
Yes.
Well, then B squared. You're going to take the B squared off. Take the B squared. Anything else? What about, do they all have A's? Nope. They all have to have an A to be able to take an A. How about all C's? Anybody missing a C? Yeah, this one doesn't have a C, nor that one. So B squared is it. That's the greatest common factor. And then you write down what's left over when you've yanked off a B squared off of every single term. Pull the B squared off here, and you're left with 8A squared. Subtract. Pull the B squared off here, and you got the 24A and the C left. 24 AC. And pull the B squared off there, and you get a plus 9. And that is your answer. That's what you'd box. You're done. If you wanted to check, though, you would distribute to check. That's what. But if you feel confident about the factoring, you don't need to check.
Question.
Go.
Again.
So in this chapter, are we going to be finding the GFC? Well, obviously we'll have them on okay, never mind. It just seems easier for me to focus on the, I've lost my mind and every piece of language that I can relate to the math class.
That's okay.
The variables and terms.
Yeah, okay.
So it just seems right there, I just saw, like, it just seems easier to take off the variables first to just clear those out.
Great. Fantastic. Let's do that first. It doesn't matter what goes first.
Okay.
That sounds great. Yeah.
Validating.
Sure. Okay. All right. The next method is called grouping. So I'm going to go, well, how many terms do you see here, by the way? 4, okay, 4 terms. All your problems in the textbook will have 4 terms. Let's see, I'll show you. 4 terms, 4 terms, 4 terms. Oh, messy, but 4 terms. So in your packet page over here, I think I would write as a hint 4 terms. Anytime you have 4 terms, figure that you would try grouping. A little hint. But you always do GCF first, every single time. And then if you have 4 terms, you try that. So if you GCF'd, it's always what's left over. Here, I'll show you some. Not that one. Okay, I'm gonna modify B. I'm gonna modify B. I'm gonna multiply all this by 5. All by 5. Okay, so my new modification is 15y plus 30 subtract 5xy minus 10x. Okay, I'm not gonna do this one. Gone. Not going to do it. Nope. So this is your B here. So I'm going to come back to that to show you what's going to happen with this. Okay. Let's go back where I left off. Now, the way I'm showing you isn't the only way that there is in the world. Nope. Other instructors have different ways of explaining it, or techniques or tricks. Your textbook also might have a different way of moving forward. I'm just going to show you a way that tends to work with most students. Not everybody, but most students. All right, so what's happening? Okay, whenever you encounter a polynomial 4 terms like this, you first try the GCF, yep. And after that, you do grouping. So here, is there a GCF? I say no. Is there other than 1? Well, how about 3? No, 3 doesn't go into 4. How about Y? No, they don't. So there's no GCF. You can't take the greatest common factor. Okay, now what you're going to do is you're going to choose pairs of terms. I have 1, 2, 3, 4. I want groupings of 2. I want a pair of this and a pair of that. So the question is, which pair do you want to grab? You want to grab pairs, both pairs, so that they have something in common. Like here, there's something in common with this pair?
Yes.
How about here?
Yes.
Okay, watch this. What if I grab the first and the fourth as a pair? Ignore this. Is there something in common here and there? Then I wouldn't grab those. Don't grab things that don't have something in common. Grab like, and most of the time when you do it, the first two and the last two, usually the way the author has them will work, usually. Not always, but usually. All right, so I grab those two and I always put parentheses around it. So I'll pick the first two to group and the last two to group, and you always, where's my highlighter, you always emphasize that. Place a plus sign right there. Place a plus sign between the two parentheses. You're not going to find this wording in the textbook, but it always works. Okay, so I grab the first, it's like taking, okay, you got to be careful. Hey, Jeff, why can't I do this? Because that will put the plus sign right there. Well, you won't make a mistake if you do that if they're all positive. If that was a subtraction, then you're in trouble. Because if it was a subtraction, you just peeled off the 4 and not the other one. You forget. So I would say don't do the parentheses, just kind of slice them. Don't do that. Grab them and rewrite them with parentheses and always put a plus sign in between. Okay, that's my hand. All right, let's see. Next, factor out the GCF from each one of these. Okay, so they both have a Y. So you pull out the Y and write down what's left over. See, they both have a Y, and there's an X plus 3 left over, and that's what you write. They both have a 4, so yank off the 4 and write down whatever's left over that makes 4X plus 12. So X plus 3. And this is good.
This will work for everyone.
Yes. Nice, isn't it? This is good. This is good. They need to, that means I'm talking about right in here, parentheses. They need to be the same. Because if they're not, then you have to start over again. You might have made a mistake on your factoring, or you have to start over again. You might have picked the wrong pair.
That's supposed to say they, not the.
They, this is good. Oh, thank you. Thank you.
This good. Ugh.
But that's just for this instance, that the two portions of the equation that they need to be the same pair, not every single time going forward.
Every single time. Every single time. Yes. Every time. Now, it won't be X plus 3 every time, but these have to match up in the parentheses. Has to. For you to be able to continue and finish. Because I'm not done yet. I'm not done. I'm just halfway done. All right, notice what's inside the parentheses are the same. This is the purpose of the step. If the binomials in the parentheses are not the same, then you should have picked a different pair to group. Try something else. Okay, now what do we do? Well, flip the page and let's see what the next page says.
Say it again. They need to be the same every single time for every single equation.
Yes.
Like in all of every
4 terms.
Jeff Clark movie.
Right. 4,
yes.
yeah. 4 term.
Every Jeff.
Yes. 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 All right. Fine. Okay. You don't believe me. I'm going to do another one. I'm going to do one over here.
No, I believe you. I just want to make sure I'm absorbing.
Okay. So I'm going to go to, I'll go to this one that I modified. and then I'll continue where I left off. I'm going to go to this one and modify. Okay, so let's see. I see 4 terms. I think I probably ought to try grouping. But before, what do you do first? What's the first step?
Greatest common factor.
Right.
Yay.
And is there one? Oh, there's a 5. Pull the 5 off. There's a 5. Yeah, okay. Take a 5 off and write down. Okay, so that would be what? 3y plus 6 subtract x, y subtract 2x if I haven't made a careless mistake. Okay, now what? Well, it's not completely done because you still got the 4 term thing to try. So the 5 is part of your answer. So you got to include the 5 at the end, part of your answer. I'm going to look inside the parentheses and do the process that I'm teaching you right now. So I'm going to leave the 5 in blue, parentheses in blue, and then I'm going to work in red this grouping idea. All right, now grouping says you pick pairs and pick them so that you have something that you could yank off, a factor. So if I look at 3y and 6, there's a 2, excuse me, there's a 3 that can be pulled off. There is a common factor here. And if I pull off something, it looks like there's an x and even negatives they have in common. I think I'll try the first pair and then the last pair. And the way I'll do it is the way Jeff says, you group them with little red parentheses. You group the other one, sign and everything, because what are you going to put in between the parentheses? That's what Jeff says. What are you going to put in between right here every time?
Positive.
Right, the positive. That's what my instructions say. It works every time. So in red, I'm working the 4 terms. In blue, it's just the first part that I took off the 5. It's part of the answer at the end. Okay, so in blue, I'll leave the 5. Big giant parentheses. Okay, in red, what's the common factor here? It's a 3. Parentheses, and I get a y plus a 2. Okay, and then what's in factor here? I'm going to take both negatives off because they have that in common. So I'll pull a negative off. Oh, and I'll pull the x off. So if I pull a negative off, here's the plus sign right here, plus sign. If I pull a negative off, it goes like right there. And I pull the x off like right here. And I put a parentheses. And what's left when I pull the negative and the x? Plain old y. What's left when I pull the negative and the x off? Plain old y. Okay, put a y right here. What's left when I pull a negative and the x off? I know I have a 2, but I pull the negative off, there has to be something left, a sign.
+2?
It is a plus, yeah. And looky here, Brooke. Well, anybody else too. Look at this. It worked. See, what's inside the red parentheses are identical. That's what you want. Yay, team. That's what we want. Because if it didn't work, then I'd screw it up somewhere. Now, I'm not finished yet because like the other problem, you know, we have some extra work to do. I'm not finished yet. So I'll stop right there and go back to the previous problem so I can look at the instructions on how I can finish this. And then I'll come back over here. So we're back over here. So once the parentheses are identical right here, you write the parentheses down once. Okay, once, right there. See, I wrote it down once. I took these two, make them away. So it's like as if I'm doing greatest common factor again. These are common, write it down once. And then what's left over is outside the parentheses. What's left over? The y, the plus, and the 4. The y, the plus, and the 4. X plus 3 in the parentheses times parentheses the leftover, y plus 4. And then we're done. And this looks like a problem that started off in 5.3. You know, multiplying 2 binomials. That's what you're headed towards. Is a 5.3 looking type of problem that starts off that way. So that's what you'd box. And if you want to check, gosh, you can just check to see if it works. FOIL, remember FOIL? Okay, x times y is x. Okay, so you got x times y. You got 4x right here, 4x. You got 3y. You got 12. So I wonder if that's how I started. I go back over here. XY 4x, XY 4x, XY 4x, XY 4x. Okay, they don't have to be in order. XY and there's a 4x. 3y and a 12. 3y and a 12. Okay, I got it. It worked. So this is the answer because I just checked it. Okay, how am I doing on time? Okay, I'm okay so far. All right, here's another one. Okay, GCF, GCF. I say there's none, but let's just double check. Okay, gosh, 2 will go into 12 and 6, but 2 doesn't go into 9. 3 goes into 6 and 9, but 3 doesn't go into 8. Has to get in all 4 of them. Oh, okay, doesn't. Okay, they all have X? No. They all have Y? No. No, there's no GCF. There's no greatest common factor. So we pick pairs. We're going to try the grouping. So here's the thing you don't want to do. You don't want to put a parentheses around there, because if you peel that off, you forgot to peel that one off. Don't do that. Do what I'm suggesting is to grab a pair. Okay, if you didn't do this right here, grab a pair. So I go like parentheses 12x cubed plus 6yz parentheses. Always a plus sign right here. This is always a plus sign right there in blue. And then parentheses. Well, the negative goes with the 9. The negative goes with the 8, of course. That's what I have down here, by the way. All right, so now we factor off the GCF. And that for the pairs. Okay, there's a 6, greatest common factor 6, and that's it. Leave the rest. Factor off the negative, okay. Factor off an X, okay. So negative and an X, okay. And leave what's left. And, these aren't the same. Don't give up. You just picked the wrong pair, that's all. The first pair and the second pair didn't work. So maybe try something different. That's what I'm gonna do. I'm gonna try some, these are not the same. That's what Brooke was kind of indicating. Will this always work? Will they always have to be the same? Yes, they always have to be. And if they aren't, then try it again. Do something different. What did I do here? All right, well, I picked something different. I put these 2 pieces together and those 2 pieces with the plus sign in between. And what am I gonna do? Well, okay, GCF here is a 3 and an X. Okay, there's a 3 and X. And you got a 4x squared minus 3z. And then a 2 goes into both and a y goes into both. Do that. And then I have this. Oh, so close. So close. They look the same, but the signs are different. That's the only thing. See, this is positive, negative, and that's, negative, positive. I mean, it's just the signs are different. It's not a bad thing. It's a good thing. So all you have to do is recognize they look the same. They're opposite signs. Pick one of them. Don't do both. I think I do the second one. And I'll rewrite this so you can see what this is looking like. So 3x parentheses 4x squared, subtract 3z, and then plus, and then 2y. Okay, now I'm going to create a negative and positives in here. So 2 negatives make, well, there's a positive. It's invisible with a 3. You guys know that, right? That's a positive 3z. But it's the same thing if I went negative, negative 3z. Seems weird, but you'll see what I'm going to do in a second just to show you. Okay, well, see the negative. How about if I wrote it as a positive negative and a 4 and an x and a squared? Jeff, that's weird. Why would you do that? Because look at, they both have a negative. So take the negative off and stick it on the outside and leave whatever is left. So if I factored off the negative, which is right there, see right there, I factored off the negative. Positive, negative makes the negative. And what's left? Well, this is going to be an, this is going to be a positive 4x squared, right, which is right here. That's what I'm looking for. Okay, see, I just rearranged the terms. That's a positive 4x. I want to try to make it look like this too. Positive 4x squared, and I stuck it first. And there's a negative left here, and I stuck it second. So that now these are the same. Those are the same. And then my last step, because they're the same, is you write down the parentheses once. Right there. And then write down whatever's on the outside, which is, here's the outside. Outside. That's the outside. That's the outside. Those two are the outside, and they go in here. And then you're done. Not easy. Not easy. You just have to practice them. Jan will help you with these three. Jan, tonight.
Yep.
I'll finish this one up, but she'll help you with those three. And there's a couple examples in your textbook too. You can see how the author does them. You can always YouTube it. Yeah. Question?
I have a question on the one that you modified, the one that we were working on before.
And I'm not finished. You're talking about this one?
Yeah.
And I'm not finished yet. So what's your question?
Oh yeah, just because I just wanted to see how you would finish that one.
Yes, thank you. Okay, so yeah, so back here, finally wrap this up. Remember I modified the original. I had this. I said, okay, how do we factor it? You start with the GCF, pull the 5 off all of them. I have 4 terms still left over. Try the grouping on the 4 terms, and I'm doing that in red. So I grabbed the first pair, the second pair, and then I did a GCF of a 3 here and the negative and the X here. And I got down here, hey, they're the same. Yay, that's what we wanted. So the last step you have to do is write down the y plus 2 once. What happens to the 5, Jeff? It hangs out. The 5 is part of your answer. Here, I'll put this like 5 is part of your answer. Okay, so write down the y plus 2 once. Okay, here it comes, y in red, y plus 2 once. And then times, and what's left over on the outside? Anybody?
Negative x and 3.
Okay, yeah, so there's a negative x and 3, but I want to do it in order. So I'm going to go 3 first, and there's a negative here and a negative x. So this is your answer with the 5. Your answer in blue at the end would be 5 parentheses y plus 2 parentheses and 3 minus x. That's your answer. That's called factored completely. Or here, okay. How about 5 parentheses 3 subtract x times y plus 2. Is that acceptable as well? What property allows me to go and do this? What property from day 1? Day 2, day 1, day 2.
Communicative property of math and multiplication.
Thanks, John. That's exactly right. How about this? Okay, well, that's true. Not wrong. It's weird. Weird because usually we put like a number just all by itself. Yes, you start off with that. You put it on the left-hand side, but it's not wrong. I would definitely keep the parentheses around it just to make sure. Yeah, so here's probably, we stop there. I don't need to go and do this at all. There's no reason. And I'm not going to check this. You know how to check it with FOIL. So Jan is going to do A, C, and D for you tonight if you come back or go to her room. Okay, flip the page, and we're going to do 6.2, I guess it is. Yeah, 6.2. Call the easy ones. I like that word.
Definitely.
Yeah, easy. Yeah, because on Tuesday it'll be the H word, hard.
They might not think these are easy.
Well, I know. So maybe, Jan, you'll make it really easy for them when you go, you know, I'm going to run through a few of them and give them some hints, some, you know, something that works all the time. But then going through as many easy ones as possible tonight, even your textbook, like do all the odds, you know, maybe as many as you can. And they'll see a pattern. I think many of them will see a pattern when you do more. So that's my thought, Jan.
Yep.
Okay, so what are we doing? We're doing what's called the trial and error. So this is method number 3. Remember method number 3 right here? So what do? You ask yourself the question, do you do the GCF? Is there something we can pull off? Yes or no? Number 2, are there 4 terms? In this section, there will not be. Because it's on trial and error, which the root word right here, try, means 3. 3 terms. Okay, so I'm going to say this one here is this is 6.2. This is 3 terms. Oh, 3 terms. For instance, if you flip the page, you see some of these extra examples like right down here. Oh yeah, 3 terms. 1, 2, 3. 1, 2, 3. 1, 2, 3. Scary, scary, scary. Scary, scary, scary. Why? Because I don't know, it just looks scary. Just extra variables in there. 1, 2, 3, 1, 2, 3. What's similar? Let's do this right here. These A, B, and C. What's similar to these? Well, let's see. They all have an x squared. No, not the same variable. Here's what's similar. It's in descending order of power. All of them are in including this one, descending order of power. That's what you want to do. You want to make sure you start off in descending order of power. Okay, what if they're not, Jeff? Well, rearrange them. Use the commutative property for addition to do that. Okay, so this is ready to factor, this one, they're all ready to factor. All right, so why is this one easy and that one? These 3 are the really easy ones. Like this one here, that's easy, but they're in the wrong order. You see this one here? This one here should be y squared subtract 9y subtract 12. Okay, so forget that. That's now in the right order. And this one's easy. Why? Because there's only a 1 in front of the squared term. That's why it's easy. The numerical coefficient of the first term is 1. Those are nice. I think Jan does about a half a dozen or 10 of them tonight. You'll see a pattern and you say, well, it's not so bad. All right, so we'll come back to these. So how do we do this? All right, well, if I look at my sign chart, now this is, the author doesn't have anything like this. He's got a different way, or she's got it, or they have a different way, whoever's writing the book, presenting it. I'm looking at as a trinomial. Okay, so if I have a trinomial like this one, that's a trinomial. You see the 2 signs that are right here? Plus, plus. Plus, plus. If you see your signs as plus, plus, guaranteed your binomial. And that's what happens. They'll turn out to be binomials. You see how the grouping turned out to be 2 binomials? Here, I'll show you. You see how all of this turned out to be 2 binomials? That's true. That'll always happen. Trinomials, when you factor, will turn out to be 2 binomials every single time. So what this is helping guide you is what are the signs going to be inside the parentheses? What are the middle signs going to be? So if you have, okay, this one here, negative, negative. Over here, where's negative, negative? Right here. So hey, these are the same. One of each sign, that's really it comes down to. Oh, if you have negative, negative, all you need is one of each sign. Order, the placement of this right now does not matter. It could have been negative and a positive, just one of each sign. Same with this. How about this one? Negative, positive, negative, positive. Right here. Oh, when I factor it, it's going to be negative, negative. So I'll refer back to this chart, and pretty soon you might not even need the chart because you see a pattern to it anyway.
Just say it again every single time for every single problem.
Keep going.
That is what will happen.
Every
single time for every single problem.
Yes.
That sign cheat sheet chart, which I will, never mind, put up on the wall in front of my computer. Every single time for every single problem.
Yep. As long as you do the GCF first, if there is a GCF and there's only 3 terms, then every single time the 2 signs that are in between. Okay. Now here's the caveat, Brooke. Do you see how all the beginning ones are all positive, like ones? Or that one's not. That's an interesting one. But see how they're all ones, what positive? There's no negative out in front. So as long as it's a positive one in front, then yes, you're right. Every single time my sign chart, my cheat sheet works. Every single time. All right, so for instance, okay, this one here. Is there a GCF? No, there's not. Isn't descending order? Yes, it is. Okay, I see a negative, positive. Go to the cheat sheet. All right, negative, positive. Right here. So I have 2 parentheses and both negatives inside. Yep, there it is. Yep, two parentheses, both negatives. All right, now how you determine what's on either side of the negative, which are binomials. The easy part is the left, because if you think about this, the only way you can get x squared is x times x. So you put an x here and an x there. That's the F and FOIL first. All right, isn't this the last, L-A-S-T? This is the first term, first. So in FOIL, that's going to be the last number. Isn't the last number over here? Isn't that the last right here? You see how a negative, negative is going to give you a positive? I'll do this again. I'll zoom in. Do you see how a negative times a negative is a positive right there? See how that's working? Give me 2 numbers here that give me 14. Well, how about 1 and 14, Jeff? Sure, that is a possibility. What's another pair that gives you 14? Well, how about 7 and 2? Sure, that's another one. Anything else besides 7 and 2 and 1 and 14? Nope. Oh, okay, so which one do you want to pick? This is the easy part. Pick the pair that gives you the middle. Somehow. Pick the pair like this one that gives you the middle. Oh, 2 and 7. Okay, 7 and 2. 7 and 2. Oh, right there. That was a minus. Just like what I did right here. Does it matter whether it's an x minus 2 or x minus 7 or switch them around? No, it doesn't matter because you got the commutative property. That was a lot of verbal explanation. Okay, now you just need to see me do a few of these. Okay, watch. Okay, like this one. Jeff says, okay, GCF. No, GCF, no. GCF. All right. 3 terms, trial and error. Okay, here we go. 2 parentheses for trial and error. Next thing is stick the signs in there. Okay, let's see. Let's do the cheat sheet. Brooke calls a cheat sheet. What am I looking? Oh, negative. Oops, here it is. Negative, negative. Negative, negative. Oh, cheat sheet says positive, negative. You can put them in that order. It's not a problem. Positive, negative. Okay, put a positive here and a negative right there. What goes in the front? It's got to give me a y squared. Well, there's only one choice. Better be a y. Don't put x, of course. Y times y is y squared. All right, now, got to put numbers in the back. Well, you got some choices. You actually have 3 choices. So I put my choices up here, and then I'm going to pick a pair that works. 1 and 12, 2 and 6, and 3 and 4. So either add or subtract. Does it give me 9? No, that's 7 and 1. See that? Can this give me a 9? Nope. Can this give me a 9? Nope. So this is an example where you tried all your options right here and nothing worked. So that this part right here is what we call prime. Remember the word prime. It's like, can't go any farther. You know, like prime numbers, not a composite. Okay, prime for factoring, you can't factor it. Basically, if we say, I can't factor it, then it's prime. Prime is what you'd box. That's what the back of the book means. Can't factor. Can't factor. It just won't work. So you would box prime. Well, that wasn't fair, Jeff, because I thought you were going to do one that worked. Okay, well, I'm going to do a couple of these that work now. The rest of them I think work. Well, no. There's actually one that doesn't, but I'm going to leave that for Jan.
I made that last
Wait, I
second.
have a question.
Uh-huh. Yeah.
So if we ever come across a problem where we can't factor it, do we just write prime, or what would we write?
On the multiple choice test, I mean, that's the important one. I get it from a test bank. It says prime. It won't say can't factor. That's my phrase. It'll say prime.
Okay.
In the back of your book, prime. That's what it'll say.
But can we write that also if we do our homework, if we come across a problem that we
Yes.
can't
Oh,
factor,
yeah.
can we write prime?
Yeah, on your
Okay.
homework, write prime. You can write yourself a note that says, I can't factor. Jeff says it means the same thing. Yeah, on your homework, look at your process. Just as long as you do some kind of process. All right, this one here. Okay, is there a GCF? No. Okay, trial and error? Maybe. Okay, put a plus plus here. Where'd you get the plus plus? In the cheat sheet. Check it out. It's in the cheat sheet. Plus plus is plus plus. Okay, then what, Jeff? Put a Z here and a Z there. Sure. Yeah, there's only one choice. Hey, look at that. 11 and 1. It works. 11 plus 1 is 12. Inner, outer. Z, 11Z is 12Z. See, if I want an inner, outer, it combines to the middle term every time. Parentheses, parentheses. Okay. Okay, well, let's see. I need my cheat sheet on this one, Jeff. Negative, negative. Okay, one of each sign right here. One of each. Negative, negative. Okay, plus here, negative there. X, X. Okay, now 50 has a 1 and 50, 2 and 25. I'm looking for 5. That doesn't work. 3 doesn't go into that. 4 doesn't go into 5 and 5 and 10. Oh, that's 15, Jeff. No, 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 no. Subtract 5 and 10. I can get the 5, but I want negative 5. Don't forget, it's a negative 5. So 5 and 10, ding, ding, ding. There's your winner. Now, it's important, since the signs are different, it's important that you pick the number and put it in the right spot. You see how I need negative 5 right here? Which number over here gets the negative?
The 10.
Correct. Because that's positive 5, that's negative 10, is your negative 5 that's up there. So it works, and then you're done. Okay, and the last one I'll do, and I'll leave Jan to let Jan do the rest of them tonight. I'll do F. F's a little weird because there's 2 variables. Okay, F. Right. What am I doing here? GCF. Oh, yeah, that's right. Forgot. No GCF. Okay. How about grouping? Do you think grouping's a good one? Brooke, why you're shaking your head up and upside down or up and down? Do this way. I said grouping. You want to do grouping on this, Brooke? Go this way. Come on, Brooke. Do this. Do this. I'll tell you why.
Wait, no, because wait.
You want to do grouping on this?
Yes.
Why? Why? Why do you want to do grouping? When do you do grouping?
Because there's an exponent, a 2 exponent on a u and a v, and then 1 in the center.
Okay. How many terms are we looking for grouping?
4.
Oh, disregard.
Right. I know. I knew that you would fit. So yeah, don't do grouping because there's not 4 terms. And that goes back to the cheat sheet. I know there's so much tonight. There's so much. Gosh darn. This whole page sounds like it's really important. Yeah, grouping, you want 4 terms. Trial and error is 3 terms. Oh, 3 terms. Yeah, so this, wherever it is, this is going to be trial and error. As soon as we do the GCF, which there is none, then we do trial and error. So then, this is maybe what you're thinking, Brooke. She might have thought the little parentheses are like grouping, but they're 2 binomials, product. And then because the signs plus minus, cheat sheet again, plus minus, plus minus, plus minus. There it is, plus minus. Oh, 1 of each sign. All right, fine, I'll put it back here, 1 positive, negative. Okay, you're gonna put a u here and a u there to give you u squared. That looks like a y, oh, that's weird. U and a u is me. There, u and u. Now, with the v squared in the back end, why not put a v and a v at the back end? Well, that's true. With the v squared at the back end, then put vv at the back end. And now the only thing left is the 15, which you've got 1 and 15 and 3 and 5, and that's the winner because I can make it 2. You just have to decide who gets the positive and who gets the negative. Who gets the positive, who gets the negative?
Three gets the
3's the positive. 5's the negative.
3's the positive. Okay, we're gonna check that. Okay, I'm gonna do that. Whoever, 2 of you said that. 2 said 3's the positive and 5's the negative. So now this is what I would suggest that you guys do on your first go at these guys. Check your work. Don't just trust that, hey, I think that's it, without checking it, at least the first few. So do FOIL, that's u squared. Okay, check, u squared. Okay, outside, that's minus 5uv. Inside is negative 3uv.
Positive.
Positive 3uv, and then minus 15v squared. Oh, 15v squared minus is good. What do you end up here? Yeah. But that's an easy fix. If you checked it, easy fix, because you got the right number, wrong sign. That's negative 2uv. All you have to do is swap the signs or swap these 2 positions. That's all you have to do. You got the right number, wrong sign.
Oh, okay. So you're saying put the 5 where the 3 is, the 3 where the 5 is.
Right, because if 5 was positive, and 3 was negative, you get the positive too. Right. So good fix. So here's your final answer. Final answer. After we polled the audience, phoned a friend, lifelines. I just did the same crazy, quit talking, Jeff.
That's my fault.
I think I fixed it now. Okay, that's positive 5 and a negative 3 is a positive 2, and that should work. That should be the answer. Okay, good.
Okay, link is in the chat.
Good session.
Yeah.
So Jan will be over there, and she can go through the other ones that I didn't get to with you. I'll stick around for 15 minutes, answer any questions you might have personally. There you go.
And I put the link in the chat.
Thank you. Link in the chat.
Thank you.
Yep. Otherwise, see you next week.
Thank you.
Jeff,
Yep.
I just had a question.
Yes, sir.
Section 6.1 in the homework is when you're dealing with those 4 terms, right? And when you're dealing with those 4 terms, how you were just doing it, you're not breaking it down all the way how you were in that example where you were doing that 5, times 3y plus 6 minus xy minus 2y, right? Because it's 2 different sections that.
Yeah, there's 2 different sections, that's for sure. Section 6.1 has 2 different techniques. Like these guys down here, you see how these got 4 terms right here?
Right.
Okay. So that's going to require grouping.
Right.
But try the GCF first, like if I put my finger on 60, for instance. Okay, GCF. 2 can go into the first 3, but 2 doesn't go into 21.
Right.
It would have to go into all of them. Okay, let's see. I don't think there's anything that goes into all of them evenly. And so then what you're going to do number 60 is to grab a pair, which I will attempt to do. You can tell me which pairs you'd like me to put together. Number 60.
You're on section 6.1, right?
Right, I thought that's what you said.
Yeah. I just wanted to make sure because, okay, yeah. That's what exactly I was talking about, 4 terms.
Okay. All right, so 6.1, section 6.1, and I'm looking at number 60. So you got, so if you can see what I'm pointing to, do you see that right here?
Yeah.
Okay, so there's 4 terms. Tell me first and third, first and fourth, first and second. Which pair? How do you want me to pair it up?
The first and second and second and third.
All right, we'll try that.
Second and third.
The third and fourth, you mean?
Yeah.
Yeah, so you got 16, you got an x cubed, and you got to subtract a 28x squared. Now, what sign is going to go between these 2 parentheses every single time?
Plus.
Correct. Then you go parentheses here, and the other ones is, it looks like a 12x and a subtract 21. 12x subtract 21, 12.
You're grouping them to 2 binomials.
That is correct.
When nothing goes into them.
That's correct.
Okay.
All right, now, is there something just for these 2 that are common?
Let's see. No.
Well, is there a number that will go in evenly, 16 and 28, the same number? Divide into evenly.
Let's see, 14, 12. No. Well, other than 1 in itself, right?
Okay, are they both even numbers?
Yes.
Okay, so if it's an even number, 2 will always go into even numbers.
Okay, so like, okay.
So 2 times 8, right? 2 times 8 and 2 times 14.
Right.
Okay, is there another number that's bigger than 2 that will go into both of them? Look at the smaller one. What other number goes into 16 evenly?
4.
Right. Okay, now you say, well, does 28 divide by 4 evenly?
7.
Right. So you know that 4 is bigger than 2. You can take the 4 out. Well, how about 8? 8 goes into 16, doesn't it?
Right. So.
But does 8 go into 28?
No.
No. So 4 is the biggest. Turns out to be the biggest.
Got it. Okay.
Okay, now the variables, you got to decide if you're going to pull any variable stuff off.
Yes, because they both have y's. So
Well, Y's, I think they're X's, but that's okay.
oh,
Yeah,
are they x's? Oh shoot, I wrote them. I guess
that's
not.
okay. But they are X's in my textbook.
Oh yeah, they are. I just okay. So x, right? So if it's x to the third power, then that means you got it, and that's okay. So it makes it 4 x cubed.
Okay, stop right there. You're saying X cubed. Now you can pull the X cube off that for sure, but do you have X cubes-ish enough here for X cube? You have an X squared.
I'm sorry, x squared. That's what I meant. 4.
There you go. There you go. Uh-huh.
Minus
Yeah,
4.
I agree.
Minus,
I agree with 4X squared.
x.
Okay, and then you got to write down what's left over after you pulled that off of both of those.
Right. So then it's 4x minus 7x. Minus 7.
There you go. 4X minus 7. You got it. Good, 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 good. That's good.
Okay, so okay, I understand. I do get it. It's just I think
We're not finished yet. I want to make sure you finish this thing up.
okay, so then that's 7, right? Okay, so then you got the other side.
That's right.
So there's an imaginary 1 in front of the plus, and then so what goes into that evenly other than 1 in itself? Let's see. Then you got 3.
Yes.
And then so because 3 goes into that 4 times, and 3 goes into that 7 times.
Agreed. Anything bigger? Anything bigger than 3?
No.
I agree. So you're gonna go plus 3 then, and they don't both have X's, so you leave it like that. And then what's left over in the parentheses when you yanked off a 3?
Okay, so then you have 4x.
Yes.
Minus, 7.
Good. And that's what you wanted, because in the parentheses they needed to be the same, and they are.
And that's your answer right there.
Not quite. No, no, no. You got one more step.
Okay, so then that's where I think I'm confusing myself, because working with maybe it's a section that I'm in, but it is a section that I'm in, because the problem 27 to the 48, those you're just leaving them. I'm sorry, I tend to go back and forth. That's the only way that I understand sections.
Okay.
So the difference between like problem 60 is that you're factoring out, right?
Versus which problem in which section?
Versus the section, the 25 to 48 right there, you're just
25 to 48. The same section?
Yeah, 6.1.
Oh, okay. So this says factor each 4-term polynomial by grouping. If it's not possible, say not factorable by grouping or prime.
Right. Okay.
Right.
That's why I was confusing myself.
So over here it'll say factor out the GCF, and then that's it.
That's it. Okay. Okay. So I get what this means now. So, but that's not it though, right? Because
Yeah, right. This isn't finished. So then what my instructions are is you're going to write down the parentheses once. So here's your writing it down once. And then times what's left over. So it's as if I pulled that off, both of them,
right.
Stuck it out here.
You have
left over.
X squared.
Yes, that's right. That's right. 4x squared plus 3. And now you're done, because it's a product of 2 binomials. Now you're done, because it is a product of 2 binomials. Excuse me.
Okay, I got it. I just wasn't there yet. That's why that was a problem, is that I wasn't there yet. But I get it.
Good.
Cool beans. Awesome possum.
Yep. Fantastic. Sounds good.
That was my question. It just threw me off completely, everything. So, but now it makes sense what you were doing.
Right on.
All right. Thank you so much.
All right, Victor. Yeah.
You have a swell night, and I will see ya
Tuesday of next week.
Tuesday. All right. Better watch. I always tell people, like Gordon always asks me, "Oh, what do you got plans?" I said, "I got church on Sunday. I got church all day." He said, "Oh wow, what church do you go to?" ESPN, Red Zone.
Yeah, there you go.
Busy all day.
Yeah, Sunday church football.
Sunday is not math day, Gordon. Sorry, we'll get back to a Monday.
Yeah.
Football, so I'll work with that.
Okay.
All right.
Here, Victor. Yeah.
You have a good night.
I will.